All right, so just to start things off, I wanted to start with more of just like a basic, uh, really basic flow problem. Just salt, just two streams of salt going into a system and then them combining and coming out, which I think is a pretty simple way of approaching this initially. So I put the problem that this is based off of in the description. So if you want to look at that right now, you can just pause it, read it real quick, and come back. But essentially, to start off that problem, to start off any problem like this, you want to be able to map out the system itself. So in the system, we have two streams entering into a system and one leaving. We have 2% sodium chloride, and then we do not know our flow. That is what we want to figure out, the flow specifically of the 2% sodium chloride. Then we have our 20% sodium chloride going in with a flow of 50 mils per second. This is going into our system. And then what is coming out is 10% NaCl. We do not know our flow, but the way that we're going to solve this, we don't need to. In fact, we can actually solve for that at the end, thanks to our conservation of both mass and of the flow itself. So you're going to utilize two equations to solve this: conservation of flow, conservation of mass. The conservation of flow here is just the flow plus the flow of 2 is equal to flow 3, which is the last one. We'll call this flow out to make it easier so there's not so many numbers. And then we're conserving our mass. Usually the way that you calculate this is that it's a conservation of mass. So it's going to be C1V1 is equal to C2V2. It's that kind of thing. But instead of having volume, we're having volumetric flow, which works exactly the same way. You just replace V with F. Since flow is conserved, ergo you can just swap them out. So here we have two streams going in and we have one coming out. So we're going to have C1 F1 plus C2 F2 is equal to C out F out. And from here, we know what we know. We need to find our F1. That is what we need to isolate. And I know that we technically have two unknowns. We actually don't have our F out, but thanks to this equation up here, we can substitute F1 and F2 into F out and then algebraically solve for F1. So what you would get here is you would get C1 F1 plus C2 F2 is equal to C out, and then you would substitute F1 plus F2. The rest of this is done algebraically, which you should be able to do, but I'll do it right here just for the sake of it. So we're going to pull this up here. We're going to distribute this across here. C1 F1 plus C2 F2 is equal to C out F1 plus C out F2. We want to isolate F1, so we're going to bring the third term over here to the left, and we're going to bring the second term here over to the right by substituting it or subtracting it from each side, or from this side and adding it to the next, So we're going to go to F1 or C1 F1 minus C out F1, right? Yeah, is equal to, this will be right over here, so it'll be C out F2 minus C2 F2. And from there you can turn this, we can just work on this side of the equation and just isolate F1 multiplied by C1 minus C out. And then you divide this on this side to isolate F1. F1 would be equal to C out F2 minus C2 F2, this in parentheses, divided by C1 minus C out. And you have all of these terms, so you can just punch this into your calculator and you should get that F1 is equal to 62.5 milliliters per second. And then from there, if you really wanted to, you could solve for the flow out, which would make this like 112.5, I want to say. I'm just eyeballing it. Yeah, I want to say 112.5. But yeah, that's basic mass balance. You draw your system, lay this out, establish relationships through the conservation of mass and the conservation of flow, and then you solve everything like a system of equations in order to get where you need to go. Just identify what you need to find, and then based on what you have, figuring out based on the relationships you've established algebraically how you're going to get there. Sometimes you'll have multiple things you have to find, and you'll be able to identify which are easier to get to first, and you'll be able to draw a map of what to find and when to find it in order. But yeah, that's basic mass balance. This video is flipped on my iPad. I'm going to try to flip it the other way. Hopefully I can.